In the last lecture, we saw that we could use subqueries to retrieve singular values. For example, what is the minimum value of experience in my dataset? But we can also use subqueries and common table expressions as well to create new tables altogether. So here's a motivating example for that. So what I'm doing in this query right here is that I am scaling the value of level based on the character's class. And you might need this in order to create some balance in your game or for whatever reason. Now, what this does is that if the character is mage, the level gets divided by half or multiplied by 0.5. If the character is archer or warrior, the level, we take the 75% of it, and in all other cases, the level gains 50%. So the details are not very important, it's just an example, but the point is that we modify the value of level based on the character class, and we do this with the case when statement that we saw in a previous lecture. And as you can see in the results, we get a new value of power level for each character that you can see here. But now, let's say that I wanted to filter my characters based on this new column of power level. Say that I wanted to only keep characters that have a power level of at least 15. How would I do that? Well, we know that the where filter can be used to filter rows, so you might just want to go here and add a where statement and say where power level is equal or bigger than 15. But this is not going to work, right? We know this cannot work because we know how the logical order of SQL operations works. And so the case when column that we create, power level, is defined here at the select stage. But the where filter occurs here at the beginning, right after we source our table. So due to our rules, the where component cannot know about this power level column that will actually get created later. So the query that we just wrote actually violates the logical order of SQL operations, and this is why we cannot filter here. Now, there is actually one thing that I could do here to avoid using a subquery and get around this error. And that something would be to avoid using this alias power level that we assign here and that the where statement cannot know about, and replace it with the whole logic of the case when statement. So this is gonna look pretty ugly, but I'm going to do it. And if I run this, you will see that we in fact get the result we wanted. Now, in the where lecture, we saw that the where clause doesn't just accept simple logical statements. You can use all the calculations and all the techniques that are available to you at the select stage. And you can also use case when statements. And this is why this solution here actually works. However, this is obviously very ugly and impractical, and you should never duplicate code like this. So I'm going to remove this where clause over here and show you how you can achieve the same result with a subquery. So let me first rerun this query over here so that you can see the results. And now what I'm going to do, I'm going to select this whole logic over here and wrap it in round brackets. And then up here, I'm going to say select star from. And when I run this new query, this data that I'm seeing over here should be unchanged. So let us run it. And you will see that the data has not changed at all. But what is actually happening here? Well, it's pretty simple. Usually we say select star from fantasy characters, right? And by this, we indicate the name of a table that our system can access. But now, instead of a table name, we are showing a subquery. And this subquery is a piece of SQL logic that obviously returns a table. So SQL will look at this whole code and will say, okay, there is a outer query, which is this one, and there is an inner query, a nested query, which is this one. So I will compute this one first, and then I will treat this as just another table that I can then select from. And now, because this is just another table, we can actually apply a where filter on top of it. We can say where power level is equal or greater than 15, and you will see that we get the result we wanted, just like before. But now our code looks actually better and the case when logic is not duplicated. If you wanted to visualize this in our schema, it would look something like this. So the flow of data is the following. First, we run the inner query that works just like all the other queries we've seen until now. It starts with the from component, which gets the table from the database, and then it goes through the usual pipeline of SQL logic that eventually produces a result, which is a table. Next, that table gets piped into the outer query. The outer query also starts with the from component, but now the from component is not reading directly from the database, it is reading the result of the inner query. And now the outer query goes through the usual pipeline of components, and finally it produces a table, and that table is our result. And this process could have many levels of nesting because the inner query could reference another query which references another query, and eventually we would get to the database, but it could take many steps to get there. And to demonstrate how multiple levels of nesting works, I will go back to my query over here and I will go into my inner query, which is this one, and this is clearly referencing the table in the database, but now instead of referencing the table, I will reference yet another subquery, which can be something like from fantasy characters, where is alive equals true, select star. So I will now run this and we have added yet another subquery to our code. This was actually not necessary at all. You could add the where filter up here, but it is just to demonstrate the fact that you can nest a lot of queries within each other. The other reason I wanted to show you this code is that I hope you will recognize that this is also not a great way of writing code. It can get quite confusing and it is not something that can be easily read and understood. One major issue is that it interrupts the natural flow of reading code because you constantly have to interrupt a query because another nested query is beginning within it. So you will read select star from, and then here another query starts, and this is also querying from another subquery. And after reading all of these lines, you will find this where filter that actually refers to the outer query that has started many lines back. And if you find this confusing, well, I think you're right, because it is. And the truth is that when you read code on the job or in the wild, or when you see solutions that people propose to coding challenges, unfortunately, this is something that occurs a lot. You have subqueries within subqueries within subqueries, and very quickly the code becomes impossible to read. Fortunately, there is a better way to handle this, and a way that I definitely recommend over this, which is to use common table expressions, which we shall see shortly. It is, however, very important that you understand this way of writing subqueries and that you familiarize yourself with it, because whether we like it or not, a lot of code out there is written like this.